So from this class, we will start the concepts of deep learning. So can anyone tell why deep learning is important?
For a large dimension data,
Okay, for large dimension data. Then any other concept? Why deep learning is important?
It will learn patterns on its own so that make our job easy.
Okay, self-learning.
more suited for unstructured data.
Fantastic unstructured data.
Useful for raw data and it can learn complex patterns.
Okay, it can learn complex patterns. Then, so before we dive into the actual concepts of deep learning, we will learn why deep learning is important. And we will learn the difference between machine learning and deep learning. We will start. So deep learning is important because it enables machines to learn large amount of data and make intelligent decisions. So that is why it is very important. It uses large data and make good decisions. So it is used whenever it is important because it has automatic feature extraction facility. It can learn the relevant features from the raw data by itself. It can be used in complex tasks. Second, it produces state of the art performance. It can be used in any task like computer vision, natural language processing, or any human level performance. It can do for image recognition, speech translation, medical diagnosis, and etc. And with respect to data, it can handle complex data. With the explosion of big data, we can use for both structured data as well as for non-structured data, unstructured data. It can be used for both the types of data, such as images, videos, or medical scans. Anything it can be used, and it can be used to extract meaningful insights from such type of data. Fourth, it can be used for advanced, like since we are all dealing with medicine, so it can be dealt for advancements in medicines, such as it can be used in drug discovery or disease prediction to enable a faster and accurate diagnosis. So it can be used in these things. Second, it is scalable, and also it is adaptable to other networks. So it can be fine-tuned for other applications without requiring any extensive reprogramming. It can be fine-tuned for other applications. And also it can be combined with other systems, like what to say, in most of the systems, deep learning functions are used, like in autonomous vehicles, uh, speech assistants like Alexa, chatbots, recommendation engines in YouTube. So in all these things, deep learnings are used. So it is applicable for many different applications. And then, as you said, self-learning. So it is continuously improving. So for self-learning capabilities, deep learning models can improve over its time because more data becomes available. It can improve on its own, so making it more robust and reliable. For these reasons, these are the importance of deep learning. So far we have been dealing with the concepts of machine learning. So why do you think we need uh, before we think why do we need machine learning? So what is the difference between machine learning and deep learning? So anyone can say what is the difference between machine learning and deep learning? How is deep learning different from machine learning? Sorry, can you be louder, please?
Machine learning, we can have some algorithm. I mean, some sort of statistical inference will be there, but deep
Okay.
learning is a black box like thing. I mean, can't be able to.
Fantastic. Okay. Any other difference?
Computational will be very. I mean, deep learning needs a very high computation.
Okay, fantastic, sir. Apart from that, so if you look at it,
Deep learning, deep
yeah,
learning also has a certain amount of the computation is there. This is there, and then it is more. You are empowering the computer, and that's where the ethics of it comes. So that is an issue. Whereas in machine learning, you think that this is not a human anyway. Okay, so you here it is able to arrive at certain conclusions where ethics becomes very dicey in deep learning. This is what I felt. The scalability, you are empowering something which you don't know much about. Like it's another human being almost like.
okay, ma'am, you are adding a different dimension to it. It's fantastic.
Yeah, I know.
Yeah. So, any other thoughts? So, both machine learning and deep learning comes under the umbrella of AI. So, both are the subset of AI. So, they have difference in terms of structure, approach, and capability. So, we will see in detail what is the difference for both the things. So, if you look at the definition wise, so machine learning is what to say, the algorithm will learn pattern from the data. Whether to make predictions or to get some extraction. So it learns patterns from the data in machine learning. So deep learning and to say deep learning is also a subset of machine learning. So it is an advanced approach of machine learning. So deep learning is not very different. It is also a subset of machine learning. It uses artificial neural network. So whichever algorithm uses artificial neural network, you can call it as deep learning. Or else deep learning algorithm uses artificial neural network to learn from the data. So secondly, the second important thing is about feature engineering. So feature engineering means, so we have to extract the features manually in machine learning. Whereas here we automatically extract the features. We don't have to specify which features we need to extract. But here you have to specify what feature you are extracting. But here it automatically extract features. You don't have to know what feature you have to extract. The third point is about complexity. So here you can use simpler models in machine learning. Example like SVM, decision trees, and regression, etc. Here you use complex models like deep neural networks, CNNs, transformers, etc. And regarding the data requirement, it can work well with small data. Here you need large data. And then computational resources here. Here with the CPU you can work, but here you need GPUs or TPUs. TPUs are tensor processing unit. GPUs are graphical processing unit. So the computational demand is quite high here, but here you have lower computation resources are sufficient for training machine learning algorithms, but you need higher computational resources for training deep learning algorithms. And performance wise, so it is good for structured data. Example, like tabular data, it is good. It is good for both structured and unstructured. Example, images, audio, text, video, and so on. And then with respect to interpretability, it is easier to interpret, but this is as somebody said, this is a black box model to interpret. It has limited interpretability. And application wise, so both applications can be done. So it is easier for simpler applications like predictive analytics, even recommendation systems. Both the things is possible for both the what to say. Almost all applications are possible by both machine learning and deep learning. So the common applications would be like predictive analytics, it can be used in medicine or in stock market, recommendation systems, image recognition, speech processing, autonomous vehicles, and medical diagnosis. So in short, we can say that the deep learning system is more advanced form of machine learning. So next time when somebody asks the question, how is deep learning different from machine learning? The first answer is that deep learning is the most advanced form of machine learning. So deep learning is also a machine learning process. So but it automatically extract features and it is well suited for handling complex data and high dimensional data like medical images, natural languages, but it requires more data and more computational power. So that is the difference between machine learning and deep learning. So,
So would
eh,
so
yeah.
So would supervised learning comes under machine learning or deep learning?
Yeah.
So supervised learning is a learning approach. So supervised learning means you will learn the data with the label. So it can come under machine learning as well as in deep learning. So you have supervised learning algorithms in machine learning algorithms also, and also in deep learning algorithms also you have it. So that is different learning technique. So learning techniques are different. How the algorithm learns the data. So that is different. So machine
Okay.
learning and deep learning is the common approach of how you follow. So if you use, so that is what we had a detailed discussion here. So if you use artificial neural networks in your algorithm, then the deep learning, the deep learning approaches uses artificial neural networks. So it uses neurons. So that is the reason we studied neurons. So machine learnings, so even deep learning, what they do, they learn from the data. They learn the pattern from the data, whether it is machine learning or deep learning, they learn the pattern from the data. But if it uses neuron, so then it is a deep learning network. So if it uses artificial neural networks. So that is different. So
CAD,
there are, yes, ma'am.
CAD. See, when you talk about CAD, earlier we used to have CAD, computer
Aided
thing for.
diagnostics.
So, does CAD come under machine learning or is it deep learning?
So CAD
Automate.
can come under machine learning as well as deep learning. So whichever approach you use, the problem is, suppose if you want to predict the disease from a mammogram. So if you want to
Yeah,
predict or grade the mammogram, so it is a it is a CAD problem. So you can use machine learning approaches or deep learning approaches for it. So you can use any one of these two to make the make your what to say application work. So the application is
okay,
going to be the same. So you are going to detect some disease from the images. So that application
right,
is the same, but you can use any technique for it.
okay.
And
Where-
and then yes, ma'am.
So when you use machine learning, you need to feed in less data, whereas when you want more accuracy, you're getting more and more data, and you're trying to make the system engage and get things by itself.
Yeah,
Is
maybe
that
I
right?
will do a small thing. So I will let's discuss that when to use machine learning, when to use deep learning.
Yes, sure.
So I will discuss that one. So it will be more clear to everybody. So before going to that, I would like to answer Anson's question. Like, so there is two different approaches. One is architecture. So architecture is different from learning methods. So architecture means what is your model made of. Learning means how this model is going to learn the data. So these two are different things. So whether you are using a machine learning architecture or a deep learning architecture, so in deep learning architecture, you have a lot of things like ResNet, UNet, and so many architectures are available. In machine learning models, so you have SPM, random forest, decision trees. There are so many models available. So the model is the models, all these models will come under architecture. In that only you have the differentiation between DL and ML. So this learning methods is how you learn the data, whether you are learning by supervised learning or unsupervised learning or semi-supervised learning or contrast learning or federated learning. So there are different learning approaches where it used to learn the data. So what to say? You can have you can have the same architecture to learn supervised and unsupervised. So you can feed in with the label or without the label. So that is how these two things are different. So you need to understand the difference between these two. So now let's go back to that question. So how to choose between machine learning? You have a problem at hand. Suppose you have an image. So you have a mammogram image. So you need to predict the disease from that image. So how to choose an algorithm? So whether you will choose a machine learning algorithm, whether you will choose a deep learning algorithm, we will see it now. So when to choose or when to use machine learning? Suppose if you have limited data. So machine learning algorithms work well with the smaller data, say hundreds to few thousands. So if your data set is in this range, then you can use machine learning. Example, suppose you are predicting the patient readmission risk in a hospital record. So for that one, you can use machine learning. And second, if interpretability is very important. We know that deep learning is a black box model, but you need to know why you have arrived at a certain conclusion. So models like the decision tree, logistic regression, these can provide better explanations. So now there is a separate domain called explainable AI. So where the deep learning models are getting explained. So people are approaching towards that one, but still if you need your models to be interpretable, then you have to choose machine learning. Suppose if you, then in what circumstances you need machine learning is that, suppose if you want faster training and deployment. If you want faster deployment or faster training, because machine learning models train faster and require less computational power when compared to deep learning. So suppose if you want to predict the disease risk of something, some disease using a mobile app, then you need to go for machine learning models. Then if the problem is not highly complex, if the problem is a very simple problem, then you think that feature engineering is also possible, then you have to choose, suppose predicting the diabetes from a demographic, patient demographics and lab data. Suppose you have the patient demographics and you have the lab results, then you have to predict diabetes. So you don't have to use a complex deep learning model. You can use a simple machine learning model to solve that problem. So based on these things, you have to choose the machine learning algorithm. The first thing is you have to choose your problem wisely. So after choosing your problem, then you analyze with these 4 points. Then you can understand whether you need a machine learning algorithm or a deep learning algorithm. So now let us understand when we need to use deep learning. So suppose if you have a very large data set, so you have millions of data. So your data set is really enormous. Then you can use machine learning data. Suppose if you want to train a model for breast cancer detection using mammogram images, you have millions of breast cancer data, then you can use a deep learning model. Suppose if your data is unstructured, so suppose if you have data like images, text, audio, video, something like that, then you can use the DL models to automatically extract features from that. Suppose if you want to detect pneumonia from chest X-rays using convolutional neural networks, then you can use DL model for it. Suppose if your accuracy is cannot be compromised. You really need a high accuracy. Because deep learning usually outperforms machine learning in complex tasks. So you feel that you need unprecedented accuracy, then you can go for deep learning. So AI-based pathology diagnosis. So for any histopathological analysis or for any such problems, any complex problems, then you can use deep learning model. And then if you have enough computational resources, then also you have enough GPUs or TPUs for training, then you can go for deep learning. So suppose if you want to do a radiomic analysis in cancer research, large scale radiomic analysis in cancer research, and you have enough GPUs to support your work, then you can go in for this thing. And the most important point is, suppose if feature engineering is difficult, you do not know what feature to extract. Because in machine learning, you have to handpick the features. So whether it is a texture feature or a shape feature or whatever it is. So if you know the features to extract, or if you know if you know the feature engineering, it is easy to do the machine learning problem. But if you do not know what feature to be extracted, in those cases, you can go for deep learning algorithms, because when domain expertise alone is not enough to extract the good features, then you can go for deep learning approach. There is one more approach also, which is called as a hybrid approach. So in hybrid approach, what we will do is that we will combine machine learning and deep learning. So what we can do for initial feature selection, you can use machine learning methods. And then for final classification, you can use deep learning methods. So for final diagnosis or final classification, you can use a deep learning model. So in this way, hybrid approach will work better. So if you don't want to compromise on the accuracy, at the same time, you want to have some features from machine learning. So in those cases, you can combine both the things. You can, this is one example I have told, that for feature selection, you are using this one, and final classification use deep learning. So you can use the other way around also. So for certain portions, you can use machine learning. For certain portions, you can use deep learning, so that you leverage both the techniques. So that is also possible. So now is it clear? Any questions? So this is what before so what kind of data? So you have to select a problem and then analyze what kind of data you have. So any questions? So after deciding on your problem, you have to look at the data first. So everything deals with the data. So whether it is a structured data means it is in an organized stored in a proper format like tables. It is easily stored like in Excel. Yeah. Can you repeat your question?
Okay, go ahead.
Okay. So if you have a structured data means which is organized or stored in a predefined format like tables. It is easily stored in like relational databases like Excel, SQL, and so on. So it is easy to organize and deal with those data. So if you have data like that one, then machine learning algorithms are best to go with. Suppose if you have unstructured data, like images. So unstructured data means it does not follow any predefined format. It is difficult to organize. So if it does not has any predefined structure, then machine learning, deep learning algorithms will be better for that one. So for most of the electronic health records, machine learning would be better. So if it is an imaging data or if it is a genomics data, so if for things like that, deep learning would be better. So any questions? So if you don't have any questions, we will start with the uh, deep learning technique now. So we will start learning what is called as feed-forward networks. So we all know that deep learning system are structured with the network of neurons. So we learned what is a neuron, how the neurons are formed in a network and all other things. So deep learning systems uses a structure. This structure is made out of network of neurons. So in that structure, we have the data which is flowing, and this data will flow in one direction, which is the direction from input to output. So all the deep learning systems have a network of neurons. In that one, information or the data flows in one direction, which is the direction from the input to the output. So far, we have been learning the machine learning concepts. From today onwards, we will start learning the deep learning concepts. So in deep learning, what will happen is that, so if it has a structure, so the input which we feed will process the data, and it will give the data to the next set of next layer. We call it as layer, and this layer will process the data, and then it will give it to the adjacent layer, and likewise it will go to the output. So one thing which you need to understand here is that, so within a layer there is no communication. Communication is there from the input to the output, but within the same layer there is no communication. So the data is processed sequentially. So this type of arrangement, you call it as a data hierarchy, or what to say, the data is processed hierarchically. For example, in human brain is structured to handle some task hierarchically. For example, processing of sensory data like vision, hearing, all these process happens in a hierarchical way. So similarly, here the data or information process in a hierarchy from input to output. So if you look at the neurons, we have learned about a neuron model called as perceptron, where you have a single neuron. The single neuron gets the input, it sums the input all together, and there is a tiny little function here, and this mathematical function will process the summed input, and then you will get an output. So if you look at this one, this single neuron is capable of separating the data. It is capable of separating 2D data with a single straight line. So suppose if you have thousands of neurons, so this neuron can classify two 2D data. So if you have thousands of neurons like this, it can do much complex tasks like image recognition, identification of faces in the photographs, and it can even perform what to say. It can even play games. So it can do multiple things. If thousands of neurons are wired in such a way, it can perform thousands of things. But what we need to learn in deep learning is that how these neurons are structured, in what layer, how these connections are formed. What is the right hyperparameter which is given to create this architecture? So how these layers are arranged. So these are the things which we will learn in a deep learning system. We know that the deep learning systems are made of a network of neurons. So we will learn what is the right sequence of layers, what is the right hyperparameter uh, for training, or what is the right hyperparameter to build the architecture. So we will also learn how these neurons communicate, with each other, how to set up the initial weights. So before the learning begins, we have to, every neuron has a weight associated with it. So we need to learn how to set up the initial weights. So what we have learned so far is that we have learned that the deep learning system is made of network of neurons. So where the data flows from the input to the output, the data flows sequentially from the input to the output. There is no communication within a single layer. There is no communication. The communication exists sequentially, or there is a hierarchy in the communication from the input to the output. And we learned that the single neuron is capable of classifying uh, two 2D data. So it can separate two clumps of 2D data by a straight line. So with thousands of neurons connected in a proper way, it can do many complex tasks. So what we are going to learn in deep learning system is that we are going to learn what is the right sequence of layer. So the arrangement of neurons, we call it as layer. So if you look at here, this is one single layer, this is one single layer, this is one single layer. So how do we arrange neurons here? How are they connected? How do they communicate with each other? So these things we will learn, and we will also learn what are the right hyperparameters for learning it. And the most important thing is that we will learn how to set the initial weights. Because every neuron here has a weight associated with it. So we will learn how to set the initial weights for these ones. So let's start with the concept called neural network graph. So let me draw a graph. So if you look at here, this is your input and this is your output. So you have 4 neurons in your input and 2 neurons at the output. So here, this is called as a graph. This complete thing is called as a graph. So this graph is made of nodes. So all these things are called as nodes or elements are vertices. So these are all nodes. So the circles are nodes, and these edges, these are called as edges or simply lines or arcs. So if you look at here, information is flowing from this node to this node, this node to this node, from input to output. So here the information is flowing like this. Here the information is flowing like this. So from one node to the other node, information is flowing. So based on this edge connections, the information is flowing. So there can be, this is in this one, the information is flowing from left to right. So there is another, so this complete structure is called as neural network graph. So we can have another type of graph also. If you look at here, these are your inputs. This is your output. Here the information is flowing from bottom to top. So information can flow from left to right or bottom to top. So based on the direction or the edges, the arrows shown by the edges, the information flows from one node to the other node. And one thing you need to know is that once the information is processed from one node to another node, the information is not getting back to the same node. Once it has left one node, the information is not coming back again to the same node. So this is one thing, it is in one direction. The information flow is in only one direction. There is another thing to note here. Suppose if you have two nodes, the information is passing from here to here. This node is called as a parent node. This node is called as a child node, or this node is called as an ancestor. This node is called as a descendant. You can name these nodes as A, B. So this is a parent node, this is a child node, this is an ancestor, this is a child. So from where the information is starting, this information is called as a parent or an ancestor. The receiving node is called as a child or a descendant. So the information is not coming back. The information is going only in one direction. So there is no, essentially you can say there is no loops. In feed forward network, there is no loops. So you can also call this as directed acyclic graph. Why do you call this as directed? Because the edges are directed with an arrow. So you call it as directed. Why do you call it as acyclic? Because there is no loops. There is no cycle. So you call it as acyclic graph. So there is only one exception to it, which is called as recurrent neural network, where there are loops. So this directed acyclic graph, I can write it as DAG, directed acyclic graphs. So these are popular in many fields because it is easy to understand, analyze, and design. There is no loops included in it because any problem associated with feedback is overcome by this directed acyclic graph. The data is flowing only from the input to the output. So it is called as feed forward graphs. Suppose if the data is flowing in the backward direction, so it is called as feed backward or backward flow or reverse feed algorithm. the word reverse, meaning it has a feedback. So there are feedback means the own output, it will receive its own output as its input. This is called feedback. So is it clear? So this is a neural network graph. It is called as a directed acyclic graph because the edges are directed. So every circle here is called as a node, vertex, or an element. These are called as arcs or lines or edges. So the information flow is from left to right or from top to bottom. There are no loops in it. This is called as a parent, and the receiving node is called as a child. So if it has a loop, it is called as a feed backward or backward flow algorithm or reverse feed algorithm. So feedback means it will receive its own output as an input. The only exception in the feed forward is the recurrent neural network where it has a feedback loop. So next, we will see what is synchronous and asynchronous flow. So in synchronous flow, what we will do is that, so imagine if there's a continuous flow. So how water flows in the pipeline. So every time there is a water molecule which is flowing in the pipe, but data is not going to be like that. So every time it is going to flow based on the chunk, every moment. So based on the chunk of data, it is going to flow. It is going to be very discrete at that moment. So because you can take like how the text information how we are forwarding SMS. So it is based on the chunk of data. It is the piece of data which is flowing. It is not like a continuum like the water flow in the pipe. So synchronous data means synchronous flow of the data means it has a master clock. So at every tick of the clock, what will happen? There will be a data flow from one node to other node. So first, when the clock ticks, the information flows from one node to the other node. Second, when the second clock ticks, this information flows from one node to another node. So at every node, the output will be processed. So between the ticks, what will happen? Between the ticks, the output will be the output will remain constant, the data will remain constant. The nodes will consume the information. Meanwhile, the nodes will be working out with the output. And at the next tick, it will pass on to its child. So this is what it happens. So if you look at it, you can look at it like an example of a conveyor belt. So multi-stage conveyor belt, what will happen in a factory? So there will be a lot of systems. So in the belt, when a product goes, when it comes to one station, there will be a processing going on. At the next tick, it will go to the next station, then there will be some processing. And then it will go to the next, at the next tick, the product will go from one end to the other end, and there will be a processing. So like this, the information is also processed. So at every tick, there will be a passage of information. Between the ticks, there will be processing of data within that node. They will prepare the output at that point of time. So this is called a synchronous flow. So asynchronous flow is very easy now. So anyone can guess what is an asynchronous flow?
It doesn't follow a direction, ma'am.
Uh,
Irregular.
what?
It doesn't follow the tick. I mean,
So there is no master clock. Fantastic. So there is no tick. So as in, so this, for this, what example we can take is that we can take an example of um, replying to a text message. So we don't follow a heartbeat or a master clock for replying to a text message. As soon as we get it, we send the reply instantaneously, or else we wait. If you are busy, whenever we see the message and whenever we have the time, we reply back. So it does not have a master clock. So the information moves as soon as it is computed.
can I give one more example? This Coursera.
Yeah.
Coursera. The Coursera, everything comes under asynchronous learning, whereas this
Okay.
class, what you're taking every Monday and Friday is a synchronous learning methodology.
Yeah, but my class is also asynchronous in a way, because you can learn at whatever time you can
Yeah,
need
yeah,
it,
it
right?
is
It is
you're storing,
recorded.
you're storing, but generally,
In general, of course, it's
yeah,
a fantastic example. You can do it at your own pace.
yeah.
Certain things, some live classes you can attend only when it is synchronous, when it is synced with the time. Fantastic observation, sir. So the information moves as soon as it is computed. So that is an asynchronous system. So synchronous system is also a special case of asynchronous. So they are not two different. Synchronous is also a special case of asynchronous, where the updates happen in a clocked way or in a logged step. So that is the thing with synchronous. So in asynchronous, every individual holds the value until it changes. So suppose we can have a, what to say, in asynchronous system, there is a problem called as new value detection problem. So what is this new value detection problem is that, suppose you have some information, but you do not know that information is a old information or a new information. Let's take some example. So you have three predecessors, three nodes. So one has an information 3, 5, 2. So you combine all these informations in a summer, you get the value output 10. So now what happens? 3 changes to 1, 5 changes to 4, 2 remains as 2. It is, there is no change in it. So it is remaining the same. So now you do not know, now these two inputs are changed, but this one is unchanged. This is remaining the same. So what you will think, there are two cases. You do not know whether this 2 is a old 2 or a new 2, whether it has computed. So whether you do not know whether this is a old 2 or it is a new 2. So what will happen here is that, suppose if you assume, if 2 is old, you are assuming 2 is old, but it might be actually new, but 2 is new. So what will happen? There will be a delay in the computation. But suppose if you assume 2 is new, but it is old, then what will happen? Then unnecessary computation will take place. So what are the potential things, what we can do here? So to solve this problem, new value detection problem, there are several steps. The first step is that you can have a versioning or a timestamp. So what is versioning or timestamp means? So you can attach a timestamp for every output. So suppose, so this is a old 2, then you fix a timestamp or a version to it. So 3.1 or 3.0. If a new 2 comes, then you fix it as 3.1. So everything has a new timestamp. And the second thing what you can do is that message counting. So message counting means, so the nodes can count how many updates they receive. So based on here, the nodes will decide how many updates they are receiving from it. So if the update is changing, it will send an update to it. Sorry, it will, here it is not going to send an update. The nodes will count how many updates it is receiving every time. So based on that, they can perform whether the new value has received from the predecessor or not. The third thing is event-based triggers. Event-based triggers means, here if the value is going to change, it is going to send a trigger. If the value is not going to change, it is not going to send a trigger. So based on that, so it can notify its successor, the predecessor can notify its successor if there is a change in the value. And the fourth thing is logical clocks. So logical clocks, so you can use the logical clocks to help determine the order of the updates. So which update is coming first, which update is coming next. So you can have an order, logical order for the timestamps in the asynchronous system because it is not clocked. So you can have a logical timestamp for asynchronous systems. So these are the some potential solutions for this new value detection problem. So in practice, so if you look at it, computer programs do not need this timestamp. This timestamp is a very useful concept when we are dealing with data for discussion, but we don't need it in computer program. So modern computers often use a wide variety of hardware and software to accelerate their computation. So it is not really required for it because we saw that the delay is the only thing which is happening here on unnecessary computation. Since because we have good hardware and software for computations, this problem is elevated. So what we did so far is that we started with what is meant by feed-forward networks. Feed-forward network means information flows from input to output in one direction, and deep learning systems are made of the network of neurons. They are structures made out of neurons, and the information flows sequentially. So we wanted to learn how these layers are connected. So we learned about neural network graphs. So we saw the components of graphs and how it is connected to each other, how the informations are flowing. If it is flowing in the backward, it has a separate terminology. And then we saw what is a synchronous and the asynchronous flow of data. So how data flows in a synchronous system, how the data flows in the asynchronous system. And then we saw what is a new value detection problem. In new value detection problem, we saw that how whether the value is changing or not and what are the potential solutions for it. So any questions? So if you have no questions, we will discuss in the next class on Monday. Thank you.
Thank you.
Thank you, ma'am.